Next video is going to be us understanding the calculations and what this graph is and why it's a little bit different from this graph, but we couldn't do the residual graph without the scatter plot and without the x's and y's. I'll just make some space over here. Okay. Not. Okay. Shouldn't be that hard, should it? Righto. So, I'm going to get you to insert a table over here. Oh, I didn't show you in the PowerPoint, sorry, that we have to write down maybe this. Okay. Can you just write down that residual? Okay, residual equals actual, take away, predicted. And that's going to start giving us the maths to justify, to show our understanding of that residual plot. So the residual value, residual equals actual, take away, predicted. So over here we'll just write it down that our residual equals actual, take away, predicted. Okay, so just a reminder that our residual is the distance between each dot and the line of best fit, the distance between the line and best fit. All of these little distances are called the residual distances. So down here, okay, we're going to make a table to describe it, because that's what this is doing. Essentially, this here is our 0 or our x-axis. Up here is our positive residuals, and down here is our negative residuals. So this is essentially, you can see the numbers match from our x-axis. But now it's a horizontal axis, but in the middle of the y's. All right, we're going to just go residual values equals actual values minus predicted values. I'm setting up a table here, okay? Okay, we have to work out our residuals. Our actuals are from our data. From our data collection. There were our actual results. Okay, so we are just going to put in our actual y results. Okay, and we're trying to predict, our y values. Okay, so to put it into context, it's like this. It's like you're saying, you know what, I collected data on grade 11 students, their height and their fitness test results, and this is what I got. And what you got is, all of these little bits of data. There you are, your actuals. But you're going to say, I want to see how a prediction. So if I didn't ever collect any data, okay, and I had to predict using my equation of y equals bx plus a, or a plus bx, and I only had this prediction line based on the equation, this is like investigating the difference between what you can predict with a formula and what you actually get with data. Okay. Okay, so I'll say that again. I guess the purpose of this plot is to compare what you actually got to what a prediction is if you didn't have any real data. Okay, so you're trying to find how close these are together. Is your actual result close to what the prediction would be using a mathematical formula, or is it not close? And you can see that some are a lot closer to the prediction than the other, or you could say some of our outcomes, which are the green, are closer to the prediction than others, or the prediction is closer to the green dots than others. So that's what we're looking at closely here today. Okay, to get your predicted outcome, however, you actually have to go away and use what we figured out in our last section of the maths, and it's sitting up here, but you have to go away and use your y equals a plus bx, which is this. It's just that this is in reverse, kind of. So it's like you have to sub it in. Just going to get rid of some of this. Okay, so with your table down here, all right, what I want you to do, please, is okay. So this predicted is like your y from down here, and it's going to equal your a plus your bx combined. Okay, so we have to work out this y. We have to work out this y column by substituting in. Okay, so our a, remember, is sitting up here really. Our y equals a plus bx. So our a is the term sitting by itself up here, and it's actually in negative. So if you could put in here negative 130.36, that is the a from the formula up here. Okay, and hopefully you've got your y equals a plus bx from the step before on your assignment. But you can see Excel can spit it out for you straight away. Okay, now you're gonna drag that down because the a is the same for everything. Okay, hang in there. The b is also the same for everything. So the b is here. It's the coefficient with this x here because the x is the height of your students. So the b is also going to be the same. It's 0.9511. And you're going to drag that down because that is the slope of the line the whole way up. Now your x is what's going to change. So remember, what we're trying to do is compare our actual outcomes to what would be predicted using a mathematical formula. So our x's are our heights. We're going to take our heights and pop them in here. Okay, but our y equals our a plus our bx. Okay, our a is our y plus our bx. Alright, so bx means we have to multiply the b and the x. Y equals a plus bx. So let's just go equals that times that, and then we just drag that down and that multiplies all the pairs through. We do not want to lock anything here because we actually want to multiply the b and the x, the b and the x, the b and the x all the way down. Now we go over here and our predicted is y, which is this, equals the a plus the bx. So it's equals our a plus our bx. So we're getting a prediction here and we can drag that down. Okay, so y equals a plus bx. And we got that equation and our our values, either from the Excel function straight away, but hopefully you went away in the last section of your report and you worked out your b equals r sy over sx, and then you plug that into your a formula, okay, and then you plug all of that into, here, which is what this equation is. Okay, now our residuals, going back to this, our residuals, our actual, take our predicted. So we go equals our actual, take our predicted. Okay. Now, what we look at here is we're looking at the residual of -6. So what that means is that let's find over here someone who got someone who got a jump of 30. Okay, so a jump of 30 is here, must be this one. Okay, jump of 30 is this one. Okay, now what is predicted? I think we need to make this a bit bigger, hey? Just so you can see where that -6 is coming from. Okay. Sorry guys, we'll just minimize this. Get out of that. Maybe draw function. Okay, so we've got this someone who's jumped actually 30. And it was predicted that they could jump 36. Here we go. I'm looking at the wrong one, guys. Okay, here we go. They actually jumped 30. And it was predicted that they could jump about 36, which is here. So what it's saying is that the residual between the actual and the predicted is a negative, because remember these ones down here are negatives and this one is below the line, so it's negative. And the difference, if I could make that graph a bit bigger, okay, the difference between the two, it would be 6. So if you said that this is our 30, and that it's predicted that they can jump 36 using a formula, the residual of the difference between the two is -6. So how that then marries up to your residual plot, I'm going to have to stop in a second because of the time. I might stop now, sorry, and I'll come back.